Alright, quantum enthusiasts, get ready for a mind-bending journey into the heart of pilot wave theory. This theory offers a fascinating alternative to the conventional understanding of quantum mechanics and might just reshape the way we perceive the subatomic world. First off, let's take a quick dive into what pilot wave theory is all about. Imagine we're in the early 20th century, the dawn of quantum mechanics. There's this raging debate on how particles, like electrons, behave. The famous Copenhagen interpretation suggests that particles exist in a state of probability until observed. But then comes along Louis de Broglie with a different idea. He proposes that particles always have definite positions and velocities guided by something called a pilot wave. Think of it like a surfer riding a wave. The surfer is the particle, and the wave is the pilot wave guiding its motion. Sounds pretty neat, right? This theory, also known as Bohmian mechanics, reintroduces determinism to quantum mechanics, meaning that if you could know all the variables, you could predict a particle's behavior precisely. Now let's break down how this works. According to pilot wave theory, every particle is accompanied by a wave function. This wave function never collapses, unlike in the Copenhagen interpretation, and it influences the particle's trajectory continuously. So, the particle is real and always has a defined path, but it's being guided by a wave that contains all the quantum information. One of the exciting aspects of pilot wave theory is its ability to explain phenomena in a visually intuitive way. For example, the famous double-slit experiment, where particles create an interference pattern even when fired one at a time. In the traditional interpretation, this is often seen as particles behaving like waves. But in pilot wave theory, it's the underlying wave guiding the particles through the slits and creating the interference pattern. What's more, pilot wave theory can offer new insights into quantum computing and quantum field theory. Its deterministic nature could help us understand and maybe even harness quantum phenomena in ways we haven't imagined yet. However, it's important to note that pilot wave theory isn't without its criticisms. One major challenge is that it's mathematically more complex than the Copenhagen interpretation. Plus, some argue it hasn't been as successful in making novel predictions. But the theory continues to intrigue and inspire physicists around the world. So, there you have it, a whirlwind tour of pilot wave theory, a quantum mechanics concept that brings real particles back into the picture. Whether you're a fan of the traditional interpretations or open to new ideas, one thing's for sure, the quantum world is as fascinating as it is mysterious. Thanks for watching, and if you enjoyed this deep dive, don't forget to like, subscribe, and hit that bell icon for more intriguing science content. Catch you in the next one.